Hey developers out there, thanks for clicking into this video where I'll be talking about the theory behind inserting data into a hash table using an array. This is a kind of second part of the array data structure video, which is linked in this playlist. If you need to understand more about how arrays work, please watch that video first because you'll definitely need that information to make light of what I'm saying in this video about inserting the data. This video is made with the assumption that a Python array works the same as it does in C++ or Java, which it doesn't actually do that. So we're kind of mocking that behavior. And by doing that, we're able to discuss the theory of inserting the data a little better. This lecture isn't really made in such a way that you can just watch it for 20 minutes and then you'll understand the hash table. You'll need to stop, rewind in places to pick up on the theory behind it a little better in more detail. Also, pull up an editor, follow along with this, and write the code in a way that makes sense to you. Definitely interact with it, and that'll make the learning process a lot more thorough. Enjoy the rest of the video. I hope you guys learn a bunch. Like, comment, subscribe, all that fun stuff. I make these videos out there for you to help you on your programming journeys, and I hope it helps. Back to our hash table demo. Let's actually make this array a little bit bigger. So we'll make this 50. We'll say size table equals 50, and then we'll change this to size table. This is important because reasons. We're going to be using the size table to decide how to insert data into our hash table, which let me take a step back and talk about the arrays. Real arrays in languages like C++ and Java. In C++ they're called vectors. But once you've used all 10 of your little buckets down here, that's all the data you get. If you need to insert more data or more customers into your application program, you would need to create a new array of a bigger size, copy over all the array, or copy over all the data from the original array into the new array, and then delete the old one. Again, it takes runtime to do, adds latency to your application, which is why arrays aren't always the best data source for some things. With a hash table, you can't really get around it. Most hash tables use arrays. I might be saying something stupid, but what I learned in comp sci is that hash tables use arrays. There might be something fancier that I'm not thinking about right now. So if you get a hash table and you use all of the slots in your hash table, you're going to add latency to resize it once you add more data in there to try to even out how you insert data, which increases your access time. Because if you insert a lot of data into a hash table, eventually you'll run into things called collisions, which is where these buckets down here will share lots of the same values. And there's two different ways you can handle a collision. You can either insert it into the next open bucket, or you can keep a running list. But if you have a list, then it takes latency to search through that list to find the specific key that maps to that hash index. Again, this is going to be a lot of kind of abstract stuff. If this is how you're learning about hash tables the first time, please do look at it, or please do rewind this and listen to it a couple times, or find someone that's talking a little bit slower than I am. Again, I'm trying to pack a lot of information into a smaller type forum. But anyways, back to this demo, we have size table equals 50. Then we're creating an array of 50 slots, and now we're going to insert some data into this. So to do that, do I want to talk about tuples here, or do I just want to insert strings? I'm literally just going to insert a string, and to do this, first we need to generate a hash of our data. So our data is, to do that, we can just use the built-in hash function. What a hash function is it's a way of converting data into a numerical representation of that data. It's a one-way operation. You can't take a hash and then recreate the data from it, obviously. And there's different ways you can generate hashes. In computer science, we just took the numerical value of the string letters. So if we had ABC A is a 1, B is a 2, C is a 3, and then you add them all up and you get a hash of 6. The problem with that is then if you have the word CAB, that would hash to the same thing and you'd get a lot of kind of collisions. So that's a very basic way of hashing stuff, but it kind of is an easy way to grasp the concept. Python's built-in hash does a lot more complex things to generate the value, and it's a lot longer than just 6. If you want to learn more on that, just Google what is Python's hash and you'll learn all about it. It's always good to deep dive the syntax of the language more to become more of a master of what's going on. But anyways, we're just going to use the built-in. We're just going to assume that it does magic, which is what a lot of computer science does if you're doing libraries and looking at code from other resources and copying it over. Generally, that's kind of a bad practice to copy over code that you don't understand, but I see it all too much. Anyways, our data is just going to be my website, via python.dev, and we're going to insert this into our array somehow. So we will show you what this is doing. I'll show you the hash, and then I'll show you what I want to do with it. I'm going to move this to a variable because it's a lot easier if you want to change things later on and you have this string in lots of places. You only have to edit it in one spot. That's kind of a best practice in programming. We'll print the hash there. Then we will create a modulo of it so that we can take that modulo value and correspond that to a slot in our hash table. And that value will always be between 0 and 50. I think if you take a modulo of 50 with 50, is that 0? I think it is. Anyways, yeah, right? Oh, okay, never mind, I'm thinking too much. If you have modulo 50, you will never get 50 for it. It'll always be a number between 0 and 49, which corresponds to the indexes of our array. So our hash, nope, that's not what I want. Our index equals our hash modulo 50. And then we will take our data and we will insert it into our hash table, which this is no longer represents an array. This kind of represents a hash table. You can also encapsulate this in a class so that you can have some common patterns to add stuff to it. For now, we're just going to do this manually. Yeah, I think that's fine. We'll talk about encapsulating data structures in a little bit. Anyways, our hash table, and then we will assign it to the index that we just created. And this equals our data. Since we know this is our first bit of data that we are inserting into our hash table, we're not going to worry about the collisions that we talked about earlier. We're just going to place it in. Normally, we would want to check if there is a value in that slot already that's not 0, and then increment our index and insert it into the next value. Or if we're using lists to store our data, which we'll get into that later in this video, maybe that'll be part 2. This one, we'll just talk about hash tables and arrays because it's already pretty long. If you want to see the next 4 data structures, the queue, the stack, the list, the tree, definitely subscribe, follow along, and I'll be posting those shortly. But anyways, back to the hash table again. Sorry for getting distracted. Now we have data. We have a hashed index by using the modulo operator, and we're going to insert that into our hash table, which actually 50 might be too big for the screen. It might be kind of hard to follow along doing that. And I didn't actually want to use 50 for this value. I wanted to use the size of the table. All right, we'll print this and we'll remove this to 20. Generally, for the size of a hash table, you want it to be a value. I always forget what it is. It's either 2 times or 6. Yeah, like 2-ish times, 2 to 3 times. If you plan on having 1,000 customers of your application, then you would generally want to initialize a hash table with 3,000-ish, 2 to 3,000-ish memory slots. And since the interpreter does this ahead of time, that is going to make your application use more memory. So if you only have 3,000 bytes of data and you're trying to create a hash table of 4,000 size of 1 byte variables, you're going to blow up the computer. Luckily, most computers have gigabytes of memory, so that's not going to happen. But it is something you want to be kind of cognizant of if you are on like a low memory system or you're really trying to create something optimized for your memory space. And again, back to the demo. Now that we have our hash table is a little bit smaller, so you'll kind of see what's going on. I'll go ahead and print this and run it. So you can see 0000, all this other fun stuff. This is our hash, 58 blah, blah, blah. This is the hash here. So feeding biapython.dev, this string into the hash value, or into the hash function, spits out this really big int. And then we take a modulo operator of it, which corresponds to the index, and it decided to put it in the 15th slot. So I'm guessing if I printed our index here, this will be 15. One thing about hashes is this will always be the same data. So that means if we're looking for our data in the future, we can feed in this key and it'll give us this thing. Actually, yeah, a hash table is usually a collection of like a key and then a data type. This is kind of a very primitive hash function in that we're just storing strings into a hashed value. You can do that by creating tuples of your data, and then the first index or the first value would be your tuple. I said that wrong. The first value in the tuple would be your hashed string. So I'll show you what that looks like. Print our index, all this other fun stuff. That actually gave us a different hash. All right, I lied to you. Python's built-in hash does not always give you the same value. Yeah, that's not what you want from a hash. The hash should always be the same value. So if you ever have questions in computer science and the program is doing stuff that you don't understand, go ahead and just pull up a Google browser and look for it. So generate a constant hash in Python. I don't want to generate a constant. I want a hash that is always the same value. All right, so in Python, there is a bunch of different ways to get a constant hash. You can use the SHA-1 algorithm. You can use an MD5 algorithm. I didn't actually, this is a little complicated than what I wanted to do, but we'll go ahead and try it. So we're going to import the hashlib library from a Python standard library that gets shipped with the interpreter. We're going to generate an MD5. This hex digest is what I'm worried about because this is not an actual integer. I don't think this is an integer either. Hash a string to a constant integer in Python. All right, so this is actually what I was looking for. This will work. Does that create a long? That's very long. Okay. So we'll keep importing hashlib. We'll still use the MD5 algorithm to generate our constant hash. And we will use the MD5 function here like we said. This will turn into our data. This hex digest will turn it into, we'll generate the hash for this MD5. This returns an MD5 object. This chains it into the hex digest function. I'm not exactly sure what this data type is, but then we convert this into an int, which apparently this is directly convertible, which is why this works. And then we'll delete the old line, and then this should just generate us constant hashes. Unicode objects must be encoded before hashing. Yes, correct. Does this need to be a byte? How do I convert this into a byte? Sorry about this. We were going pretty good. And actually, yeah, okay. I didn't know if my mic was working. That would have been a pain. Turns encode string in Python. I'm pretty sure it's just .encode, but I don't remember if I need to tell it what to encode into, or if I just call .encode. Yeah, I think I can just do this, and it will use a default encoding using UTF-8 to turn this into a byte representation, which the byte representation will feed into the MD5 algorithm. And that's 0. I don't know if that's always 0 or if I messed up. I may have messed up something. So if we add some random data into this. Okay, no, it did actually just convert into 0. All right, so this was our hash. Again, very long integer, and it just happened to be the 0 index of the array. When we add on some fluffy string characters onto our original array, we get this new hash, which goes into the 16th slot and goes here. So again, this isn't really super practical in that we're just storing strings, but let's go back to assuming that this is a customer or like an email address, and that email address corresponds to some other data. All right, we're gonna get rid of our via-python.dev string, and we're gonna turn this into an email address. So user1@gmail.com. And let's say this user has a first name, a last name, Stefan, that's me, and last name. And maybe he has monies. Maybe this is like a game character, and this is 1,000 monies. Now you can't actually encode a tuple, which that's what we're using to represent this data is a tuple, and our tuple is always going to assume email, first name, last name, and then their monies in that format. So tuple with some basic assumptions of the data we are storing. Now we can take our data and we can encode the first value of the tuple. Tuples are immutable, so this will always be the same contract and we can't actually change it. But we can access it using the bracket notation that you would use to access values in an array. We will encode it. We will print our hash. We'll do the index. This is the same operation. We will use the index to insert it into the hash table, and instead of inserting just a string, we will actually insert a tuple. So that way we can retrieve it in the same way. By doing the same process of using the email address as the key, converting that into a hash, and then printing our data, and then the index of that. And since we've already calculated the index on this before, we will just use it from up here, and we'll print this out here. Go ahead and run this, and then we'll talk about the output. Again, this is our long hash using the MD5 function. This is that value once we take the modulo of it, and then we insert our data into that slot in our bucket, our array. And then printing our data, our index, we show this guy, user1.gmail, which that isn't exactly right. This shouldn't actually be our data. This should be our hash table. And then this will retrieve all of the data for us in constant time by knowing the index, because we can take the hash of it and then we can retrieve our data that way. So if we are logging into a game and we put in our email address, the application's business logic will be able to go through that process to return the data to the application in a much faster time than if we had to search through millions of entries of different game users. That's why the hash table is extremely useful in coding applications. Luckily for us, we don't need to do all of this little stuff. I just kind of wanted to talk about the basic theory of a hash table. Python does have a built-in hash table called the dictionary. So we can do our dictionary equals dict, and this will give us that fun stuff. So we can do pretty much what we did before, and inside of our dictionary we can add our value, and we can use we can use the email address to insert it into the data by doing our data.0, and that key will equal this tuple value, and then we can retrieve it. Very similarly, our hash table, actually we're using our dictionary now, and we will use our email address as the key here. So instead of putting indexes directly into it, we're putting in keys, and then the objects of the built-in dictionary type will do all that conversion for us, where it does a hash, converts it into a modulus based on the size, inserts our data into that index, and then retrieves it in the similar fashion. And Python will automatically resize our array for us once our data gets too big. This dictionary also handles collisions for us, which I briefly talked about before, and it's very handy to kind of use these built-in functions so we don't have to implement a bunch of stuff from scratch. And normally these are much more optimized than things that you might implement on your own anyways. We'll go ahead and run this and show you that we get the two of these tuples for our output, which one is here and the other is here. And I'll run that for you now. So now we can see. Now we can see we have those two different tuples down here, tuple from the hash table and then the tuple from the dictionary, both accessed in constant time, so we can get data to our application much faster than if we were just storing it in a really large array of millions of customers. Thanks for watching along so far. I thought I would get through this faster, but apparently it takes a lot longer to kind of talk about the theories behind the two data structures. And I hope you do follow along for the queue and the stack, and then the list and the tree. These are more linear data structures. These are a little more non-linear, because instead of using arrays to store the data, we're using nodes, and nodes can be joined together in all sorts of weird, crazy ways. And again, follow along for that video if you want to understand what I'm talking about in more detail. Again, thanks for following along. Have a great day. Take care. Bye.